Okay. Recap from the last time. I talked about CNN, convolutional neural network, which is some kind of deep learning architecture that have receptive field. Now, I'm going to demonstrate how we can create that type of model using Torch framework. In this case, we are going to try to classify this dataset, the CFAR10, the image recognition problem with 10 classes. First of all, we have two important one, and there is another specific library called Torch Vision. We help you to do things with the image processing. Okay, and after doing that, record. Oh, I did it already. Okay. For now, we have to create a transformation that transform normal image into some kind of transform it into more proper way, and this code is wrote the dataset, and we define the loader here. You don't have to worry about that much. And this is the classes we have here in this dataset. There are plane, car, bird, cat, deer, dog, frog, horse, ship, and truck. So we have to feed the image into the model, and that model have to be able to classify this, separate it. Okay, let's run this block itself, and then run this cell. Okay, this try to normalize it. Anyway, just follow the code. Okay, this is example of the dataset. As you can see here, it randomly pick 5 images for you. There is something, maybe a cat here, and there's a frog and truck here. And the image is quite blurry, but you don't have to be worried that much, because normally when we create deep learning model to do some kind of image classification, with this size, the model can still understand this image. It's still predictable. If we feed a big picture into a model, the model will have to be in bigger size, and it will have to spend more time to train it. So that's why people try to reduce the size of image into this very scale first before training the model. And now we're trying to create a model which is CNN model. You can copy this code and use it in your project. Anyway, I will tell you what it is so that you can change the parameter of each model. For this one, it creates the convolution layer. Convolution layer is actually what I told you before from the last break. It's like you put a filter into each of them, like this one. This is convolution layer. And for pool, after you create this number, after you create a convolution filter, you have to do some kind of pooling operation. For pooling operation, there is some kind of operation that reduce the size of the result from the last one. For example, this is a filter, and in this case, the pooling layer is trying to find the maximum number that appear in a filter. For example, in the top right, it is 8, right? And on the top, actually this is top left. Top right, this is number 5 here. And this is 9. And this is 5. So the final result will be look like this. Pooling layer can be with different operation. In this example, it's called max pooling because it finds the maximum number. That it can be average pooling, it can be anything. But in this case, we use max pool 2D. And then we create another convolution layer and then feed it to the linear. There is 3 linear. We call this one actually we call it dense layer. And then we have to define the feed forward method here. From X, we have to pass the convolution layer and pass it to activation function like this one, and pass this result to the pooling layer like this one, and do that again here in the second convolutional layer, and then pass the result X to flatten it and to the dense layer like this one. And this is our model here. Okay, let's run this one. Okay, And after that, we have to define loss and the optimizer. In the last time, the loss is NLL loss, right? But in this case, we are going to use cross entropy loss, which is some kind of function that compare the entropy between the predicted result and the actual result. Don't worry what entropy is. It's quite the concept is not that hard, but you don't have to focus on the detail much. But anyway, this is another method to compare to find the loss. For optimizer, in this case, and at the last time, we use stochastic gradient descent. We pass the model parameter with the running rate 0.1. In this case, we also pass the parameter with the learning rate like this one, and we also pass the momentum because we don't know what it look like in gradient. Maybe the gradient can be look like this one. So if we add the momentum, instead of the parameter go from this one to this local minima, it will help the optimizer train the model faster. It will skip this hole and maybe go down to this global optimum. However, stochastic gradient descent not guarantee global optimum, but it is good enough. So we are going to use this one and then run it. Don't forget to run it. Don't forget to run it, and then we are going to train this model. As always, do not forget to clear the gradient, and then we do the feed forward and back propagation, and then optimize like this one. And we are going to show the loss every 2000 millibatch. Let's run it. We'll spend some time, a little bit, before it finish running this cell. Okay. Anyway, why this model running? Let's have a look at another cell. If you want to save this model and use it next time, you can use this command torch.save. Actually, there is so many ways to save this model. You can search that on internet. But in this way, I'm going to save it like this one, net.static class. So that after we train this model, we can save the model into our device. And for next time, we don't have to train the model. We just wrote the pre-trained model and use it. If you want to do your own project, your own business, you just save the model and use that later. After saving the model, of course, it's time to test the model. In this cell, we are going to test the model with the ground truth. Or actually, in this code, they're trying to load the testing dataset first. Show you the actual target of the example image. And then we are going to load the model from what we have saved. We have saved model to this directory, right? And now when you want to load it, you can use torch.load and pass this path into that function and put this result into this function, this another function. So now the model is loaded. Okay, the training is finished, and as you can see, the loss is decreasing. Well, actually, we trained this model only two epochs, but with different mini batch, because we cannot train the whole batch, because that data will not be able to fit into our memory. So we have to divide it into a small batch and train it one by one. Now the model is saved and we can load the model. Okay. Okay, this is the test. This is the test set. The first one is cat, and this is ship, and this is plane. After we load everything successfully, we can pass the testing dataset into model. So we get output here. Let's have a look at the result. Okay, it's not that good. Actually, this one is cat, this is ship and plane. But the result from model is floor, and yes, ship, but not plane here, it's a ship. So I conjecture that this model perform well on ship data, on ship image. But for frog, I think even me, I cannot identify this one. It looks so blurry. I don't know what it is. It's like an arm of someone, and this is some chunk of, I don't know, organic being or something. I don't know. So in this case, I think it's okay to misclassify. Anyway, if you are a machine learning practitioner, you shouldn't be okay with this result. You should find a way to train it. You may have to increase the epoch or maybe create more complex model. Anyway, I will leave it to you to try to improve the performance. And let's have a look at the overall result. So in this cell, it will pass the big chunk of data set into the model, and the result, the accuracy is 54%. Oh, it looks bad, isn't it? But well, it's like a toss a coin. Anyway, if you carefully think about that, the probability of you doing it right for this data set is 110, right? Because there is 10 classes. I think this is baseline. If you want to randomly assign the label into testing set, the result should be 10%. Accuracy should be around 10%. But this one can do better than that. I think it's okay, but it would be better if you can. I think we can improve it. I'm not sure the how far can we go, but I guess I conjecture that I think it should be around 98%, maybe 99% with the. I think this is the best people can do on this data set. Actually, this one I'll tell you, it's actually better than 10% accuracy. Okay. Anyway, let's see which class is not perform well. Let's run this one. Which class? Okay. As you can see, the cat here is not doing good in with the cat image and bird here. If you want to improve it, maybe you have to have a look at the cat image and think about how to improve it. Maybe you have to add more cat image. Find different view of cat and bird. Anyway, I will leave it to you as a homework that you don't have to hand over to me. How can we improve this model? You maybe add this epoch, or maybe you can increase the complexity, but I'm not suggest you to do that. Or maybe add more dataset on these two classes, but you have to be careful that you might introduce another problem, which is imbalance class. So be careful on that one. Okay, Let's have a look at the final model before we taking a break. I'm not sure how many of you want to predict the time series of something. For example, stock price or maybe some kind of sentences. In that case, there is a thing called sequential model that can do this task. There is so many kind of sequential model. For example, hidden Markov model. This is one of the name of the model. If you have learned statistics, you may know this name, the Markov chain rules or something like that. But in this case, it is hidden Markov model. Or maybe the conditional random fields or RNN recurrent neural network is also a name of sequential model. However, the one is that is quite popular to tackle with time-series data is called LSTM or long short-term memory. Okay, I will tell you about this one later, but I will talk about the data that you will feed into this kind of model. For example, if you have some kind of number, let's say number 1, number 2, 3, and after 3, it go back to 1, 2, 3, something like that, one like this. And you want to feed this into model, some kind of model. And you want model to predict something. For example, if this one is at the t equal to 1, this 2, this 3, 4, 5, 6. Your model, maybe you want to feed the t here, the data at t, and you want it to output the predict data at 3 plus 1, like this one. So in this case, you pass the t here, it will produce 2. If you pass the 2, it will produce 3, something like this. Anyway, maybe you can pass if there is 1 and it will predict 2, you can also pass the state from the last time to the next state. Because sometimes if you get the result 2, but if it's not, sometimes if 2, it can be 4. Like this one. This 2, you have to predict 3. But for this number 2, you have to predict 4 because it came from 2, like this one. So you may pass the hidden state here to the next one, like this one, so that model can be able to predict the future better. Anyway, if you want to know more about LSTM, which the concept is quite complex. You can click the link here. It will direct you to another collab that is not mine. In this collab, it tries to explain you the concept behind LSTM memory, why it's a long-term, short-term memory, because it can remember things, and it also can be able to forget things. Well, there is a lot of mathematical notation here. Anyway, I think it will be too deep in for this class. So let's have a look how can we train it, how can we create it in with the Torch framework. As always, you have to import Torch, and don't forget to set the seed so that your code, your experiment can be replicated. Well, unfortunately for you, you don't have to implement this one by yourself, which is quite complex, right? You can just use this function. nn.lstm, it will create LSTM architecture for you. You just pass the number of input dimension, like this one, it's 3. And you pass the output dimension, which is also 3. And in the first example, they just random the input. In this case, they just randomize it. And also randomize the hidden state, because this is a best practice for you to randomize the parameter before training. So in this case, they just feed this randomized input one by one. This is the first one. Then pass this one to LSTM and pass the hidden state to this model and get the output, and then get the hidden. Actually, if this is the hidden state for state T, the result will be for 3 past 1, like this. And if you want to pass the whole batch, this one, into the model, you have to transform it first. You use the torch.concatenation input together into some kind of torch object. And then this one, they re-random the hidden state and pass the input, and also as well as hidden state here to get a result. So you don't have to pass one by one. I will show you what it looks like. But let me run this thing first. At first, you create this input. The result will be look like this. So you have to pass this one to the model first. You pass this one into your model, and again and again. But if you don't want to run it by your own self, you want to just push everything fetch into your model. You can use this one to transform the input first. See, the result will be in tensor object like this one. Well, but we don't do anything here. We just pass the value into some kind of function and get the result. We didn't train it yet. Now, we are going to solve one of the NLP problem, which is we want to create a model that be able to tag path of speech, POS. For example, for the here, we want to tag this one as determiner. For dog here, is it noun, right? For age here, is it verb? We want to do this kind of problem, and well, actually, this is a training set. This is the only training set we have. We will train this program with two records here. And after we run this code, it will prepare the result for you. Well, as I told you, we cannot fit this word into your model. We have to transform it to be a number like this one. Number 1, number 2, number 0, 1, 2, something like that. And we have to also transform the label here into a number. Okay, I think now the dataset is ready for us to be used for training. And this is the class of the model. First, you have to create a constructor method. Yeah, this one is called constructor. When you call this function, when you want to create this one like this, you have to pass the parameter here, and this parameter here will go into a constructor. So you have to define this one. It will save the hidden dimension here, hidden state dimension, and embedding dimension here, as well as vocabulary size and the target size. And at first, the result will be passed into, not the result, the input will be passed into the embedding layer like this one. It will embed the input into some kind of vector, and then pass that vector into an LSTM module like this one. Actually, this one is the input dimension, which yes, it is embedding dimension, yeah. And this is output dimension of LSTM, which is the hidden dimension here. Then we pass, not yet. We create the linear layer to receive this output from LSTM and do some kind of prediction. For feed forward will define the flow of the data. For example, you feed the sentence here into word embedding. It will embed this sentence into some kind of vector, and you pass this vector into LSTM, and you get the result here. And you also pass the result here. And the result from the linear layer here will be a text space. And then we pass this one to the softmax function to get score. Let me show you how it looks like after we pass the information into this model. And in this cell, we are going to train the model, which is quite fast. It's finished. Now we have to create the object, the model object here first, and create a load function, which is actually the same as word to vec, right? For word to vec, we also use this kind of load function. This one is the same, and you create the stochastic gradient, the optimizer, which is stochastic gradient descent, and you train the model the same way you did it before in convolutional neural network and word to vec. You have to create a gradient, prepare the data set, pass the feed-forward input into your model, and then do back propagation. 4 steps here. And after that, in this one, it shows you what result look like. In this one, we pass this sentence. The dog ate the apple. This is the sentence. The dog ate the apple. And at first, before we train the model, we also print the score. And after training the model, we also print the score here. So the first one is from before training the model, and the second one is after we train the model. Let me translate this result for you. As you can remember, we want to tag each word. We want to tag the path of speech of each word. There is 3 categories, which is determiner, noun, and verb. The column here represents the probability of each word. For example, the first column is death, determiner. The second one is noun. For the first one, if you want to predict which, there is a first word here, and the highest chance, the highest one, is actually number 1. Number 1. And for this one is number 1. And for the second one, it's also number 1. I guess it is all 1 like this one. So this model, if we go into the lookup table, which is let me find it. Okay, this is lookup table. If you have a lookup table, the number 1 actually mean NN, noun. And the sentence is the dog ate the apple. It means it predicts everything to be a noun, which is not correct. But if you consider the one after you train, this one, the first word is actually the maximum one is 0 here in 0 column. The second one is in number 1. And the third one is the word 2. And the fourth one, okay, this is third one. The first one is also number 1. Oh no, 0. And the last one is number 1. If, as you can see, the first one is determiner, noun, verb, determiner, and noun. I think it looks correct. Let's compare with the sentence here. The first one is determiner, which is the, it's correct. The second one is dog, which is noun here because it's number 1, correct. The third one is verb, which is we here, correct. And the determiner, and then the noun. Okay, I think this one is better now. But there is so many ways. It doesn't have to be with this application. You can adjust it to do some kind of, well, stock price prediction or COVID mortality rate from this one and so on. You can adapt it. Okay, I think it's the time that we should take a break. And for the next one, it is your turn to update your project. You don't have to be, it doesn't have to be in office or in informal way. You don't have to prepare your presentation. You just tell me the progress of them. And if you have a problem with that project, you can ask me. Okay, anyway, let's take a break for 10 minutes. And we go and we will go back to you.